Okay, yes. So I think my voice is clearly audible to all of you and my screen is visible. So it's been some months that I started your inhomogeneous differential equation solving part. This is the solution of inhomogeneous differential equation. I already told you that in your semester 1 you learned how we solved the homogeneous differential equation, right? So the inhomogeneous part will be in semester 1. I told you all that the inhomogeneous part will be in your semester 4 syllabus, that is in your semester 4 mathematical physics part, DSCC 7 paper. Okay, so I already started inhomogeneous differential equation solving classes, and I took one class few months ago, not few months, 1 month I think, 1 month. So because I think you're already familiar with that, your semester 6 seniors exams are there, so I took more classes for them, and it's done now. Now it's your exam. It's also will be in 1 month, so it's your time now. So I think if you already followed the previous session, that is I think lecture 22, so already had idea about what is a inhomogeneous linear differential equation, okay, and how we're gonna solve it. So there are different cases, and for different cases different rules to solve out the inhomogeneous differential equation, particularly the particular integral part, pi part, because CF, that is complementary function part, is already familiar to you all. This is in your semester on syllabus, okay. So before watching this session, if you forgot or not follow the lecture 22, the first session of ordinary differential equation, I request you guys to do the same, because uh, if you don't have any clear idea about just differential equation, then it will be okay. So let's proceed without much talking. So first, for your convenience, guys, I'm gonna write the general form. Let's make it a little thinner. Yes. The general form of differential equation. Okay, it is the Euler forms, Euler's homogeneous differential equation. Let's write it down. So what is this? This is nothing but P0 dny by dx to the power n plus Pn d. It is 1 means here what we will have dn minus 1 and dx n minus 1 ellipsis plus what will be the last term? Last term what happened? P0, P1 dot or P1, P2, that will so on so forth ongoing, and in the end term we have the coefficient at Pn, and when the coefficient is Pn and suffix is n means, so what will happen in d power n minus, that is 0, so something to the power 0 is what? 1, so 1 by 1 is 1, so equal to what? Capital X. So what is this P0, P1, and this is a simple coefficients dot dot dot, that is Pi's, okay. So Pi is what? Pi is what? This is nothing but Pi is, and also what? These are not capital X. Okay. These are some constants. Okay, these are some constants. Or a function of X. Okay. Not function of Y. So why it will be not function of Y? You may mention it in comment section, but also I discuss these things, and this is quite familiar to you all, and because you all in your semester 4 now, and this is your lecture or eight lecture, and these are the things quite familiar to you all. Okay, so that's let's so the point is that how we will treat a homogeneous differential equation as homogeneous or non-homogeneous. Okay, the main part is that right hand side, capital X part, is constant of X. Okay, so if capital X equal to 0, then what will have? This left hand side equal to 0, so this is a homogeneous differential equation. And what makes this homogeneous is a inhomogeneous differential equation? The right hand side is not equal to 0. Okay, so not equal to 0 means there are some functions or some constants are there. So depending upon the functions and constants, there are different types of cases, and for particular cases, there are different types of rules are there to solve out the inhomogeneous differential equation, right? So I already mentioned you have one thing, that's LIAT. This is a partial integration solving you studied in your HS, and E for what, exponential. And in previous session we already discussed about how to solve a inhomogeneous differential equation. PI part, it is particular integral part, when capital X of x equal to what, e to the power x and x to the power n. Okay, so something by e to the power x or e to the power x by something, and f of d and x to the power n by f of d. So what are the process and how we are gonna solve it out? These are the things I discussed in previous session. I request you to follow the same. And this is the, I think, lecture 22, and it will sorry, it is also it was also uploaded in YouTube for freely for all of your convenience. Okay, so now today I'm going to discuss the third case. Let's use different color for that. That is case 3. Okay, so case 3, in case 3, what, in case 3, capital X of x equal to what, some trigonometric function, that is t. Okay, so trigonometric function means what, in this case we only use the two trigonometric operators, that is sine e and cosine e. Okay, so let's consider we have sine ax, so a is some constant. Okay, and cos x. Okay, so what will happen and how in this case, and how we're gonna solve about the inhomogeneous differential equation when on the right hand side we will have sine x or cos x, right? So let's write it down. So suppose let's take a differential equation second one. Okay, x plus dy by dx. So let's keep it until now, and in right hand side we have sine x or cos x. Okay, we will solve out for a particular problem, and here I am going to tell you the rules how we're gonna solve it out, and we're going to show you guys some proofs how we will solve out that particular part when we have trigonometric function as sine x and cos x. Okay, so what will happen? So the CF part is quite familiar to you, complementary function parts. It is quite understandable to you, and you will going to solve about the complementary function part quite easily. Okay, so in complete solution, what we have? We must find y complete solution. It is y. So y equal to what? These are two parts are there. Y CF. CF means complementary function part, as well as y pi. Pi means the particular integral part. Okay. So right here we already know how to solve the complementary function part. Okay, but in case of inhomogeneous differential equation, we have different forms of different functions and forms of capital X, and depending upon the different functions or functional forms or constants, we will have different types of rules are there to solve out a particular integral part. So in that case, what we will have? We have the trigonometric sine and cosine operators. Okay, so how we will gonna solve it out? So what will happen in this case? Y pi equal to what? Y pi equal to nothing but what? Simple case, that is what? Sine ax. Okay, let's write it down first as sine ax. Okay, or cos ax. Okay, and in the denominator, what we will have? We have what? We have function of d. We have function of d. But here there's a little trick to solve out a particular differential equation. Okay, so now I'm going to tell some things to you. Let's suppose x square. Okay, x square plus 4x plus 3. This is a quite polynomial you have on your hand. Okay, this is a polynomial, let's say. So how we'll write it as a function of the polynomial, particular polynomial. So this is a polynomial, and this is nothing but function of x. Okay, so I'm gonna write it as a f of x equal to this part. Okay, this is a function. Okay, this is quite familiar to you all. So now the particular point that I'm going to tell you guys, that there's a term x square. Okay, so in this particular rule, that is when capital X equal to sine x or cos x, here we will not gonna write f of d. Okay, suppose this is a function of x. Okay, this is a function of that particular x square part. We will also write it as function of x square. Okay, so if this is a function of x square, so now the question arises. So x is there. So how it is? We will tell you that it is a x here. Okay, so now the point is that we write this as function of x as well as function of x square. Okay, so how will the two things are same? That's the point. I think it is quite familiar to you, and that I am gonna repeat it out for that. So here function of x here, that is x square is there too, and x is there and constant term is there too. The variable is independent variable is here what x, but x square, how we will gonna write this term as x square too? Because here the first term is x square and here this is x. X means what? Root over of x square. So here this is the square term is there, so we will write it as function of x square, and here this comes here x means what? Root over x square, so it will be plus 4s either or minus 4s, so that will not gonna happen. Sorry, that will gonna happen. Okay, but that will not gonna make this not a function of x square. Okay, so if this is a function of x, this is a function of x square too. So for that purpose, in solving this type of particular integral part where we have sine functions, then we write this function as f of d square. Okay, so now the question arises, if y pi is equal to sine x by f of d square or cos x by f of d square, then how we will gonna solve out that particular type of inhomogeneous differential equation. For that case, when we have trigonometric sine and cosine functions, now we will gonna learn that part, how we will gonna solve out that part. So when we have sine x and cos x part. Okay, so now that's it. I'm gonna solve it out with using and show you with using some examples. So first, uh, write a little bit of things that I want you to please see that part, and I will show you how to solve it with using some examples. And right now I'm gonna solve out some parts, some things that mathematical expressions or for that particular part sine cosine that I need you to see. Okay, let's write it down. So the point is that if we differentiate sine x, okay, so what we will have? So d of sine x is what? Is nothing but what? A cos x. Okay, but we differentiate it again, that is d square. Here d means what? D means d by s. I think this is already familiar to you. I already told you these things. And if d square sine x, then what we will have? This means d of d sine x. So d sine x is what? A cos x. So a cos x. Okay. So after that, what we will have? dA. So here's another a is there, but cos x differentiating, what we will have? Minus sine x. So we have here minus a square cos x. Okay. Now again, if we d to the power 4 sine x, so that means what? D to the power 4 sine x means d square into d square of a, sorry, not a here, sine x. Okay, d square into d square of sine x. So d square of sine x is what? Here we will have minus a square cos x. So if minus a square cos x, we will differentiate it, the minus a square cos x part, if we differentiate it twice, same as the previous. So what we will have? We will have here cos x means on another, if we solve cos x, sorry, differentiate cos x again, so what we will have? Let's take a little time. Cos x we will have, so sine x, sine x, here we have cos x. So cos x means cos x will also become minus sine x. After that it will become cos x. Okay, so if we differentiate is 4 times, so what we will have? We have minus and minus, so minus minus cancel out, 2a, 2a will be there for that, here 2 and a square, so we have 2 4 a to the power 4, so minus a square minus a square, what we will have? A to the power 4, and also we have cos x. Okay, so a to the power 4 means what? Minus a square, that whole square, this will become a to the power 4. So right now I'm going to write a thing here, that is write it as minus a square the whole square cos x. Okay, so what we will have? We will have d to the power 4 means d square whole square, and here we have minus a square whole square, and this is cos x and this is sin x. Okay, so now I am going to show there's any mistake. D to the power 4 sin x. Oh, I mistake little here. This is not cos x. So these are the things quite ongoing recorded session, since you have no time to attend the live session because your practical pressure is too much for college. So if this is a live session, that things you will gonna tell me, and this wrong mistakes will not gonna happen. So sin x cos x means again we have sin x. Okay, and here also we will have sin x. This is why I am telling you that something's quite uncomfortable to me because I am going to prove something is sin x, is sin x. Okay, so right here what we will have, d to the power 4 means d square whole square, that is, yes, I'm going to show you a little thing. Let's see that if what we will have, d, if we put d square sin x, we will have minus a square sin x. If we put d to the power 4, that is d square whole square sin x, we will have minus a square whole square sin x. So sin x part is quite common. Okay, but if we write the differentiate it again, that is, I want to say that d square whole to the power n sin x is equal to what? Minus a square whole to the power n sin x. Okay, a not 2n. If we had n equal to 2 or 2, we may write is at 2 and 2. Okay, so the point is that if d square is quite ongoing, that is the 2 4 6. Okay, here why we write n, when we put here we take the minimum value of n is what, n equal to 1. So 1 2 3, if we go is that process, then if n equal to 1, then what will happen? 2 2 means 4, 3 means 6, so on so forth, that things will going forward. Okay, and we also have sin x as the results, and the coefficient term, the constant term will come out as minus a square, the whole square cube. That is the things to the power c. That is the things quite ongoing. Okay, so what we had here, d square whole to the power n means this is a function of d square. A function of d square into sin x equal to, so this is, yeah, so this is the things I am trying to prove for now. F of minus a square sin x. Okay, so this is a very important results that I am trying to prove for now. Uh, Through that results, or through that process, or through that proof, we will gonna find out how, what is the rule, or how we will gonna solve out the homogeneous differential equation when capital X of x equal to, or right hand side equal to some sine or cosine functions are there. Okay, so if f of d square sin x equal to f of s square minus sin x, and same thing will happen for cos a square too. So cos x too. So this is I'm gonna write it in next step. But what I need to find, sin x by f of d square will be what? Okay, so how are we gonna find them? So we need to find sin x by f of d square. Okay, so multiply both side by f of d square. Okay, so what we will have? Let's go side sin x equal to 1 by f of d square, f of, sorry, f of minus a square, f of minus a square into sin x. Okay, so f of d square cancel out in the left hand side. So what we will have? We have in the left hand side only sin x. Okay, so sin x equal to what? 1 by f of d square into f of minus a square into sin x. Okay, so what will happen next? We need to find sin x by f of d square. Okay, so let bring this f of minus a square in the denominator of the left hand side. So what we will have? We will have sin x by f of minus a square is equal to sine ax by f of d square. So what, yeah, this is the rule that I am going to try to find out for that long proof and long kind of purpose of kind of things. Okay, so this is what we have. We have sine ax by f of d square is equal to sine ax by f of minus a square. So d is eliminated. So this is the solution of that part when we have sine f x by f of d square. It is become sine ax by f of minus a square. Okay, so now I think if you guys followed the previous session in exponential part, we also mentioned that when f of a is equal to 0, then do gonna fail and kind of things are ongoing. So same kind of things is ongoing here. Sine ax by f of d square is equal to sine ax by f of d square if and only if f of minus a square is not equal to 0. Okay, now if f of minus a square is equal to 0, then what we have? We need to differentiate the denominator, right? So what will gonna happen for this part? For it first, if f of minus a square equal to 0, then something by 0 which is infinite. That is how we'll not gonna first find out find out the solution for this problem. So what will happen next if f of minus a square equal to 0? So this is the things I think quite familiar to you all from the exponential root. So ax will be there, and we will have sin ax, and we need to differentiate f of d square part. It is if dash minus if that d square, then in that part we will put minus a square. Then what will happen? F dash minus a square. So this is a solution of the inhomogeneous differential equation when f of minus a square is equal to 0 and f of minus a square is not equal to 0, f dash. And if it's 0, it is then what will happen? This is x square by sine ax by f double dash minus a square. So this is the rule. I think if they are quite familiar to you all, same as the exponential. In case of exponential, we have e to the power x term, and same things. If of a is equal to 0, then we need to differentiate. The same things will ongoing for that part. Okay, so this is a rule for that solving differential equation when we have sine e and cosine e. And if we have cosine e, that is cos x by f of d square, then we will also have the differential equation solution as cos x by f of minus a square. Okay, why? Because here we find out or try to prove try to find out the solution of the differential equation when we have x, and if we put here cos x, I request you guys do the same by your own. So we will also have same differential equation or same equation or same expression or equation, say whatever it is. Sine, in terms of sine x, it will be what? Cos x. So through that we will find same solution of the differential equation, and same things occur, that is if it is 0, then it will differentiate and put x and x squared, same kind of things are quite occurring to you all. And I think till now the rule of solving the differential equation when we have sine and cosine quite familiar to you. So it will be clear to you all if we solve an example. Okay, an example. So let's try to find out an example. Here it is. Okay, so let's try to solve some answer. First, I'm gonna solve an easy problem. Easy means shorter one for better. Yeah, it is cos 2x. Okay. So now the point is that the complementary function part, how to solve, I think it's quite familiar to you all. You need to take some trial solution, mx y equal to e to the power mx, whatever it is, and after that there are some auxiliary equations are there. From the auxiliary equation, depending on the behavior, or sorry, the kind of roots, it is equal or unequal or complex conjugate, then depending upon that you will have some different kinds of uh, complementary function forms are there. Okay, so I request you to guys do the part of complementary function by yourself. Okay, and I think d square plus 4. So what we will have? We will have m square plus 4. That is, yes, that is a complex conjugate part is there. I think because m square plus 4 equal to 0 means m square equal to minus 4, and minus 4 means whatever this is I is there, so m square equal to minus 4. If we find m square equal to minus 4, and what it is plus minus 2y, okay, because my root over minus 1 is I, so the complex conjugate parts are there. So what will be the complementary function part? So y shape is nothing but what we have, e to the power alpha is this alpha plus minus I beta form is there. Then we have a to the power alpha x into a cos beta x plus sin beta x, okay. So here it is alpha equal to 0, so first term will be not there. So what we have simply a cos 2x plus b sin 2x, okay. So now the main part, that is particular integral part, ypi. So ypi equal to what? So ypi is nothing but what? Cos 2x by d square plus 4, okay. So here d square term is there. So if we compare it in the above rule, so what will be there in the above rule? That is cos x by f of d square is equal to, the solution is what? Cos x by f of minus a square, if f of minus a square is not equal to 0. So a is equal to what? A is nothing but here a equal to 2. So let's put d square, uh, uh, let's put e equal to 2 in d square part. So d square becomes what? F of d square is equal to f of minus a square. So what will happen? Cos 2x by, in terms of d square, so we will have minus a square, that means minus a means what? 2 square plus 4. So what we will have, cos 2x by minus 2 square means minus 4, minus 4 plus 4, that is 0. So something by 0 is infinite. So here the rule fails. Why? Because here f of a square is what? F of a square is minus a square is 0. So what we will have? We need to bring x here. In numerator we have cos 2x, and in the denominator we must differentiate it. So after differentiating t square plus 4, what we will have? We had simply 2d. So 2d. So if we want to solve the differential equation, or differential equation, sorry, not differential equation, inhomogeneous differential equation from this part, we must bring a term d square in the denominator, okay. Because if we want to make a function of f of x, and that is, there has to be a term f of x in the equation or expression, what is x are there in the polynomial. So same thing occurred in that part here. You need to bring a term where we have d square, okay. So how we will bring the d square term? Simply, the one thing I want to mention, that in that problem we don't require to bring d square term in the denominator. Why? Because we already had x by 2, okay, and we have with 1 by, sorry, 1 by d cos 2x. And what we mentioned in the lecture 22 as previous session, that d means differentiation and 1 by 2 means integration. So 1 by d means integration, so 1 by d cos 2x is what? So integration of cos mx is what? Cos mx by x. So x by 2 into 1 by 2, sorry, cos 2x, integration cos 2x means sin mx by x, okay, mx by m, it is mistake for me. So 1 by 2 sin 2x. Yes. So d is eliminated. So what we will have, the particular integral part? We will have x by 4 sin 2x. Okay. So the complete solution yc is equal to a cos 2x plus b sin 2x plus x by 4 sin 2x. So this is the complete solution of the given inhomogeneous differential equation. Okay. So let's try to solve another problem. Okay. Let's find another problem. Yes. So I request you guys, I'm gonna give you the problem, and request you guys to pause the video and try to solve the problem by your own, and after skipping it down, and let's find out a solution, and you may match it, and if it's matched, then congratulations, you learn that part. And if it's not, so don't worry, you may see it again and try to solve out the another problem, another assignments. I will gonna keep in the next minutes for your homework purpose. Okay, so let's try to find. Yes, d to the power 4 minus 3d square minus 4 into y is equal to 5 sine 2x minus e to the power minus 2. So, okay, so let's try to solve this problem by your own. You may pause the video and try to solve it out. I'm not gonna make that video too long for that one rule, so I'm going to solve out that problem. So the CF part is quite common. So here part is what? M to the power. So let's try to write the auxiliary equation. Auxiliary equation what? M to the power 4 minus 3m square minus 4. Okay. So that is what? 4 minus 1, that is equal to 0. And that for solving the complete function, there's some writing some things are there. I need to mention that please write the things that uh, in your exam purpose. Otherwise, it will deduct some marks from you. And I'm just going to try to do it in shortcut. So 4 minus 1, so it is m square. Sorry, yes. 4 minus 1 is 3, so m square minus sign is there, so this is m square minus 4 into m square plus 1 is equal to 0. This is the things we will have in here. So two parts is there, it is m square plus 1 is equal to 0 and another one is m square minus 4 equal to 0. Okay, so m square minus 4 is equal to 0 means m equal to what? Plus minus 2. Okay, and this part minus 1, m square is minus 1 means what? M equal to plus minus I. Okay, so what we will have the complementary function. So YCF is nothing but, so 4 means 4 different terms are there. So 4 different terms means 4 different constants. Okay, so for that plus minus I and plus minus 2. Okay. So plus minus 2 means one term, one root is plus 2 and another root is minus 2. So for that part, let's write it down as a e to the power 2x plus b e to the power minus 2x. Okay, plus for that complex conjugate part plus minus I, let's write it down as c cos x plus d sin x. Okay, so this is the complementary function part. Okay, it's quite easy, and I need to find out the particular integral part. So let's try to find out the mean. Y is equal to f of d square is what? D to the power 4 minus 3d square. After that minus 4. Okay, and in the denominator what we will have? We will have simply 5 sine 2x minus e to the power minus 2x. Okay, so let's separate these things. That is 5 sine 2x by d to the power 4 means d square whole square minus 3d square minus 4 minus e to the power minus 2x by d to the power 4 minus 3d square minus 4. So this is the exponential part. I told you the rule for exponential part, how to solve that exponential term when we have the inverse differential equation. So I need you guys to follow the rule and solve that part, and just try to find out that part. 5 sine 2x, so here a is what? A is 2. So if a is 2, 5 is there, so a is 2 means minus 2 square, so minus 2 square, it is what? Minus 4. Minus 4 the whole square means what? 16. So write it down, 16 minus 3 minus 2 square, that is minus 4, so plus 12. Okay, plus 12 and minus 4. So this is not equal to 0. So this is quite easy to solve it out in the than in the first expression of the problem. There, I think you imagine that is tough and quite long. So this is not going to happen. It is quite easy problem for you. And for that part, what will happen? F of a means what? F of a means minus 2. So minus 2. Let's put minus 2 here. So minus 2 divided by 4 means 16. So 16 minus 12, that is 4. 4 minus 4 is 0. Okay, so in the first time it will not gonna happen. So let's write x. Okay, and x e to the power minus 2x, and differentiate at denominator. Differentiate what we will have 4d cube minus 3 to 6d minus 0. Okay, so this is what we have. And what we have here, 16 plus 12, 26, 28 minus 4, 24. That is 5 by 24 into sine 2x. So this is quite easy, and this part, although I again put minus 2. Minus 2 gives minus 8. So minus 8 into 4, minus 32. Okay, so minus 32 plus means here minus. So minus 32 plus what? 12. So minus 32 plus 12 is minus 20. Okay, so x e to the power minus 2x by minus 32 plus 12, that is minus 20. So it is not equal to 0. So it's done. 5 by 24 sine 2x minus 20, that is plus. So x e to the power minus 2x by 20. Yes. So this is the particular integral part, and if I did any wrong in that problem and in the previous problem too, in the full session, so any part, we mention it in the comment section. Okay, so what is the complete solution for that? YCS is nothing but a, what is the complementary function, 2 minus 2 1 1. Okay, so a e to the power 2x plus b e to the power minus 2x plus c cos x plus d sin x plus 5 by 24 sine 2x plus x by 20 e to the power minus 2x. This is the final solution and complete solution of the given inhomogeneous differential equation. Okay, so I think the rule is quite familiar to you. How we are going to solve the differential equation, inhomogeneous differential equation, when we have sine or cosine functions. Okay, so let's try to solve another problem. After that, I will give you some assignments. Okay, let's try to solve one problem again. So here it is, d square minus d minus 2 into y is quite easy, sin x. Okay, so YCF is what? YCF is nothing but this. I'm gonna write it by calculating by my own. I may try to solve it and write some things to solve the complementary function part. Okay, so m square minus a minus 2, that is a minus 2 into m plus 1. So the roots are 2 and minus 1. Okay, so this is nothing but a e to the power 2x plus b e to the power minus 6. Okay, so now the particular integral part, ypi equal to what? Sine x by d square minus d minus 2. Okay, so what we will do now, the sine x by f of d part. So here a is what? A is equal to 1. So d square is minus 1 square. Let's write it down here. Minus 1 square minus d minus 2 sine x. So minus 1 square minus 1. So what we will have here? We will have a simply sine x by minus 1 minus 2 minus 3 minus d. So let's take a common of negative minus. So we'll have sine x by d plus 3. Okay, now the point is that in the previous part I also have that kind of terms, but here only d is there. So 1 by d is simply the integration of sine x. So here a term extra in addition into plus 3. So it is not going to happen quite easily, so we need to bring a d square term in the denominator part. So for that, what we will do is simply multiply both sides, denominator and denominator is with the conjugate term, that is d plus c. Multiply it both sides is d minus 3, so what we will have minus sin x to d minus 3 by d plus 3 into d minus 3 d square minus 9. Okay, so let's bring the d minus 3 in the vector side, and here we have sin x by d square minus 9. So same process as previous, minus d minus 3 into sin x. So sin x by d square, it is minus 1 square, so minus 1 square minus 9, that is minus 10. So minus 10 minus minus plus, what we will have 1 by 10 into d minus 3 into sin x. So let's multiply d minus 3 into sin x. So 1 by 10, d of sin x means what? Cos x minus 3 sin x. So this is quite easy. Okay, so what is the complete solution? Why complete solution is what? If we, the roots are in complementary function, what are the roots? A e to the power 2x plus b to the power minus x. Okay, let's write it down here. Plus 1 by 10 into cos x minus 3 sin x. Okay, yes, this is the rule. So I think that rule or that case, when we have the diagonal function as sine and cosine, so I will gonna solve it out. I think quite familiar to you. So I'm gonna give you some examples. So try to solve it by your own. Take it as an assignment. So I'm gonna tell you and mention you one thing, that in previous session I also gave you some assignments and many students send me there in WhatsApp. So don't worry. Those who are some registered candidate, you will also receive that. I'm gonna solve out everything by my own hand, and I'm gonna send you. I'm gonna upload you in classroom, but since this class is freely available on YouTube, so if anyone want to solve, and the number will be provided in thumbnail, you may send it WhatsApp me this examples. Okay, and I'm gonna, if you try to solve these things, then as the previous some students did that, so I will send you the solution in through WhatsApp, through which you send me the solution, and you may knock on the WhatsApp too. So Dada Bhaiya, anything, whatever you told me, to send me the solution, all kind of things. I am to send you the previous assignment solutions too. So for that class, let's do take two assignments, and if you solve that two assignments, I think not any problem. We're gonna bring any disturbance in your exam. Okay, so we're quite comfortable to solve it out. So let's try to solve out the two assignments. Again another one. Let's take d cube minus 3d square plus O.D.E minus 2, that is 2, okay, into y equal to e to the power x plus cos x. Okay, so I request you guys, please try to solve that problem by your own, and you may try to, if you watch it in recorded, you may try to solve that by your own hand. When you saw the recorded lectures, try to do the write the things as we write in your in the right session, same flow. Okay, that is writing here and you watching the session, and doing a written copy, and so and try to write the things in live, and also try to on the same sitting. Okay, the same sitting was the recorded session, and try to write it down everything I wrote in there. I'm gonna give you the paperwork, that's not a problem, and notes everything, but try to watch it and live, and sorry, record it, and try to write everything in your own hand, and on that same sitting solve that two problems. That will not gonna bring many time to you, and if you do everything in same sitting, it is एक टाइम पे बैठ के सब अगर सब एक साथ सब सॉल्व कर दो तो आपको कोई प्रॉब्लम नहीं होगा बाद में एनी प्रॉब्लम सॉल्व करने को. ओके, दिस इज द थिंग्स आई एम गोइंग टू टेल यू. ओके, सो फॉर द सेशन दिस इज okay, and good night, and we will meet the other rules of how to solve the in my differential equation. There are some things that when we have other functions, right? And we also other function and other, they are only single function, other two functions, e to the power x into h to the power n, two function multiply. These items of rules are there. I will gonna show in the next session, and also I am gonna show you the one general rule that is clearly mentioned in the syllabus, is Wronskian method, through which every problem we're gonna solve quite easily. And in that part, the the thing I want to mention, that's we need to integrate something. Okay, the integration terms are there. The integration is quite tough sometimes in some problems. This is why there are different types of rules and for different kind of functions are there. And please try to memorize everything, or memorize or solve, practice everything, so you will not gonna face any problem in your exam hall. Okay, so okay, thank you, good night.